In the previous few videos, we discussed the concepts of process, system, equilibrium, and first and second law of thermodynamics. In this video, we are going to deal two things. One, the Carnot cycle, and reversibility. Before moving into Carnot cycle, we will need to learn what reversibility is. So, what is reversibility? When a process, assume a process like this from 1 to 2, if a process happens like this, it is said to be reversible when it is performed in such a way that at the conclusion of the process, that is at 2, we should be able to take the process back to 1 following the same path, which means we should be able to bring the process back to the original state without affecting either the system or its surroundings. So there should be no change to the system or its surroundings, and when we take the system back to its original state. It is an ideal case. So a reversible process is an ideal process, which means it is not real. All actual processes are irreversible. So reversible process is a idealization of the actual process, or the limiting case of the actual process. In other words, we can say reversible process is not practically possible. So what are the causes of irreversibility? We said reversible process is not practically possible. So let's see why is it not possible, and what are the causes of irreversibility. Usually the causes of irreversibility are lack of equilibrium, and dissipative effects. Whenever you have a process from 1 to 2, it is not possible to keep each state in an equilibrium condition. You can't keep all these states in equilibrium, because at 1 it may be in equilibrium, at 2 it may be in equilibrium, but the intermediate states, they are not in equilibrium with the surroundings. So that is one cause. When you do a process, it is not possible to maintain the equilibrium throughout the process. And second is dissipative effects. Dissipative effects can be many things: heat losses, friction losses, lack of pressure equilibrium, etc. Friction is always there. Whenever there is a work transfer, there is a friction involved in all cases. So these are the two reasons for the irreversibility of a process. Actual process cannot be reversed. Friction is the major dissipative effect. In every work transfer, there is a friction effect, friction involved in it. So you cannot, in an actual case, you cannot produce a work transfer without a friction, without a frictional loss. So a process will be irreversible when it is performed in such a way that the system is at all times through the process is near at thermodynamic equilibrium with the surroundings, and also there shouldn't be any dissipative effects. Whatsoever be the form, there shouldn't be any dissipative effects. So it should be in equilibrium throughout the process. Say for example, you consider something like this. Let's call this a process, and each of these points should be in equilibrium when you have a process from 1 to 2, which is practically impossible. And one more condition: there should not be any dissipative effects in any of these states. Dissipative effects in the form of friction or heat losses or work losses, etc. So these are the conditions of a reversible process. Now we move on to Carnot cycle in the next video.